All right, and we're back. So today we're going to continue talking, and actually on Wednesday as well, next class, okay? We're going to still continue finishing up the logistic regression, and we're doing the same example, right? The bank data, personal loan, okay? So in the previous couple of classes, what we did is we discussed simple case, right? We said that the likelihood of a person getting a loan from the bank when offered depends only on income, right? So we made it simple. We said nothing else is important. Income is the only thing that defines if the person will get a loan or will decline the offer, okay? They were going to expand it, right? They were going to include more predictors in our model. And also, what we will do is we'll recall our good old approach when we train the model, and after that we validate the model to see if it suffers from overfitting, right? If it performs well or equally well on the data that it did not see before, okay? So we're going to split the data set into the training and validation, okay? Do you have your RStudios open, ladies and gents? If not, then open it. Okay, open your RStudios. And I trust that you all downloaded the data for the bank already. It's sitting in your data folders, right? Okay, so let's start the code from scratch, essentially, okay? So first things first, I'm going to say bank data. First thing that I always do is I bring the data in the memory, right? So read CSV file, and it's sitting in our C drive in the folder data, and it's called bank.csv. Let's see how much you remember. What CSV stands for? Comma separated values. This is probably by far the most popular way to store the data for the analysis like that, okay? So I'm going to run this line. I read the data. Now let's take a look at the structure. Is that required step? Sometimes I do we have to do it? No, we don't, okay? It's just kind of a nice practice, right? You read the data and you see what's inside, what it looks like. Bank data, all right? So our target again, we know that already, right? Is going to be personal loan, and the answers are zeros or ones. One, if the customer was contacted by the bank and they did apply for the loan. Zero if they ignored it, right? And everything else is the predictor. Age of customers, experience, income, family size, etc., etc. Now, some of the predictors are numerical, some are categorical, right? So, for example, securities account. The values are yes or no, or 1 or 2 in our case, right? Then CD account. Do they have CD account or not? Same thing, okay? And education is the one that's kind of a little bit twisted, complicated, right? In a sense. Why? Because it has 3 levels. There is a BS, bachelor's, MS, master's, and doctorate for PhD, JD, etc., etc. Okay, cool. All right, so first things first, let's split the data set into training and validation, okay? So I'm going to start typing comments again, okay? I stopped doing that at some point. So split the data. Okay, first set the random seed. Why are we doing that? Because we want to split into the training and validation set to be the same for everybody, right? Because if we split it differently, you and I, or all of us, will end up with different models, right? So set random seed. Okay. Set dot seed, and let's just for simplicity use the value 1. Okay. Doesn't really matter which value you use. It's all just it will be kind of telling the program how to split the data set, right? Okay, set seed 1, and now let's split it 80% for the training, 20% for validation set. Okay, so get a random sample. By the way, I have 5,000 records, right? According to my summary structure of the data, I have 5,000 records. Okay, get a random sample of let's see, 80% of 5,000 is what? 4,000 numbers, right? Numbers out of 5,000. Okay? So I'm going to call it random sample, random underscore sample, and that would be what? Sample, and I have to say out of 5,000 numbers from 1 to 5,000, get me 4,000. Simple as that, right? And then I run it, and I shouldn't see any red warnings, right? You remember we were doing this, and you did that for the project as well, right? Should be painfully familiar. All right, good. So now I'm going to say all records that correspond to the random sample numbers, they are in my training set. And whatever is left is my validation set, right? That's how we did it in class. So I'm going to call it training underscore set. Training underscore set. And that is from the data, bank data, okay? Square brackets, pick the indices, pick the records that correspond to the random sample. And then I say comma and leave it blank. Therefore saying that take the entire record, all columns, okay? All columns. So that's my training set, and validation set is going to be whatever is left over, right? So I'm going to say bank data, and here again square brackets, but I'm going to say minus random. So remove the records that correspond to the random sample, right? And whatever is going to be left over, that's your validation set. Random sample, and again comma and blank, okay? Nothing. So now I have to, and I need to run this one as well. Well, just for the heck of it, let's take a look at the structure. I should see 4,000 records and 1,000, right? That should be my split. So therefore I'm going to say structure of my training set, and there it is, 4,000 records, that's 80%, right? Just like what I expected. And again, just to be on the safe side, let's take a look at the validation set. Structure. Yes, ma'am. Oh, from the previous example? Yeah. Yeah. Yeah, I understand. Yeah, so probably what you need to do is this portion, which we never used, right? Where it says environment, it just basically shows you what's in your memory, right? So here's what I probably would clear objects from the workspace. Bam. If I do that, then it's going to go away, right? So let's see. Now if I type validation set, and it's still showing up, right? Well, let's see. Validation set. Yeah, error. Validation set not found. Okay. So when you clear, so if you load the RStudio, apparently what it does basically is all things that you used to do, it keeps in your old session, stored somehow. So therefore, yeah, things that you did before for different examples, it still can pull out from them, right? So from this standpoint, what helps is just clear it out of the memory so it doesn't remember anything, okay? Now I destroyed everything, right? Pretty much. So now I have to run the whole thing again. Alright, so I'm going to select, that's actually how I do it, okay? Every time when I need to rerun the code, I just select it all and just hit Control Enter, and it does it, okay? So, yeah. Alright, so we have separated our set into the training and validation. Are you with me? Everybody's keeping up? Okay, good. Next is I will use training set in order to build my logistic regression. Cooper? Sure. Oh, okay. Good question. So, Cooper says basically, why do we have comma and then nothing, right? It's weird, right? It's weird. Let's try this. I don't know if it's going to work or not. What will happen if I say training set? I'm just trying things, right? 1, comma 1. Let's see. If I run 1, comma 1, it says no. That's weird a little bit, right? What is no? Okay, so now let me go ahead and take a look at the training set. And I don't want to look at the entire training set, so here's the function that we never did before, okay? You learn something every day. Head. Head stands for header, right? So if I'm going to take a look at the training set header. Training set, oh god. Training, I can't help it. Training set header, okay? It will give me only first, what's that, 6 lines, okay? And the titles of this, of the columns, right? That's the header of the data. Look at that. My very first row is number 1328. Why do you think it's 1328? Any ideas? Because when I created the training set, remember, I created random sample, right? I'm willing to bet that this is the first number in my random sample. Let's see if I'm right. So I'm going to say random sample. Oh god. So the first number is 1328. Do you see that? The very first number in my random sample. Hence, for the training set, it picked the record with the number 1328. Okay, so this is record number 1. This is column number 1. Okay, so when I said training set 1, 1, what I'm saying really is give me first record, first column. Okay, and that's why I see this null. Now, back to Cooper's question. Okay, Cooper says, why do you have comma and then nothing? Okay, so if I say something after comma, that means I'm looking at the specific column, right? But when I have comma and nothing, it means take them all columns. That's what really means, okay? I know it's looking weird, right? Something, comma, and then nothing. So basically it says that all columns that you have, bring them. Okay? Alright, so I'm going to keep that in head training set. Alright, so now I have separated my data set into training and validation, and let's train the model using the training set, right? So this time around, I'm going to call it multiple logistic regression, right? Because I'll have a lot of predictors, right? So comment, just like I promised, right? Train multiple logistic regression model. Okay? Bam. Alright, and that's what I'm going to call it. Multiple logistic. I'm sure it's not the right title for this, not the right way to call it, but, well, multiple meaning many predictors, right? That's what it means. Multiple logistic regression model. Okay? Bam. Alright. Which function do I use, remind me? For logistic regression. LM we use for linear model, right? For this one we're using GLM. G stands for generalized, right? So it's linear in its core, but then you do the weird transformation. In our case, it's logistic function that transforms the regression, right? So I'm doing GLM, and I have to pass GLM 3 parameters. Number 1 is, what's your model, right? What's our target? Personal loan, right? Personal underscore loan 0, 1, okay? Tilde, what are my predictors? Everything else. So I have to say dot, right? I don't want to type them all. And then comma, of course I have to say which data to use. Which data should I use? Training set, right? Training set. And also the last one, I have to tell GLM function which transformation to use, right? In this case should be logistic function, right? So I'm going to say family. I told you that each time when we have something else, right, in the function R part we said method equals class, right? This time around we call it family, right? When you predict, you say type, right? These are the types of things that you probably should put on your cheat sheet, right? To remember which function takes what's the parameter called. In this case, it's called family, okay? And the family, quote unquote, should be binomial, okay? Binomial basically is to say that you should use logistic function, hence we're building logistic regression, okay? Run it. It should give you no red warnings. All right. Well, let's take a look at the function, okay? At the model, right? What do we do next? Summary, right? We do summary of my model. Multiple. Yeah, as I start typing, it says, yeah, I know what you mean. I have this variable inside. Okay, good. So let's go ahead and run this one. And the output, the model summary, I'm going to make it bigger. Just like that, okay. Looks a lot like what we saw in the case of the multiple linear regression, right? Not multiple logistic regression, this one, but multiple linear regression. And same rules apply, okay? We can go ahead and test the significance of each variable. So just like for the multiple linear regression, in this case we can separate variables that do make contribution to the model from the variables that are useless, effectively, okay? So, reminder, what we do is this, okay? We test hypothesis, whoa. We test hypothesis. Null is always that the slope of the variable is equal to 0, which means that the variable is not significant, right? We can replace the slope with 0. And the alternative is always the slope for each variable is not equal to 0. And then we find the p-value, right? And compare it against alpha. If the p-value is less than alpha, that means that you keep the null, right? Keep the null hypothesis, okay? No, reject null, sorry. Okay, reject, right? P-value is less than alpha, you reject null, and therefore variable I is significant, right? It has to stay in the model. So that's the rule that we use, okay? So therefore we're looking for high p-values, right? That's what you did in your projects, right? How did you eliminate the variable? If p-value is high, compared to what? Compared to whatever alpha we pick. And the standard value is 0.05, right? So let's use the same rule for our model, right? Okay. So I'm going to eliminate the predictors that seem to have high p-value, therefore they're not significant. And I'm starting with the highest one, right? We call it what? Backwards stepwise elimination procedure, right? So what's the most useless variable? Tell me. Say what? Well, scientific, yeah, good idea actually. Scientific notation, right? So all this e minus 16, right? Okay, let's get rid of them. How do we do that? Options. You see, guys, you practically like fearless tigers of R, right? You know your way around it. Options, sci-pen equals 999. Okay, I'm gonna run this line, right? So here I'm gonna say get rid of scientific notations, right? Okay, so I run this, so I should probably move it higher, right? Even before I do the model summary, something like that. Okay, then I'm going to rerun the summary. Okay, no scientific notations. It's all good. So what's the most useless variable that I have to get rid of? Age, right? How old is the person? Apparently has nothing to do with how likely they are to apply to the loan. So I'm going to go back to my model and say everything minus age. Rerun it. Now I'm going to skip the options. Summary. Okay, age is gone. I still seem to have couple of more variables, right, that are not making contribution. What's the next one to go? Mortgage balance, right, has 0.5 p-value. Very high, right? Has to go under any value of significance. So mortgage, mortgage underscore balance, right? Hope I didn't mess it up. Yeah, that's fine. And then let's do the summary. Okay. And there is another one, experience years, right? 0.18 p-value. That one should go as well. So minus experience years underscore years. Okay. I'm going to run the summary again. Bam. All right. Well, everything else seems to be significant, right? So everything should stay in my model, right? Have the same output. All right. Now let me go ahead and write it down. Okay, that one is kind of important. So here I'm going to say comment model equation. Okay. So do you remember that we a couple of classes ago discussed that here is one way how to write down the model. You can write it like this: probability of response 1 is equal to 1 divided by 1 plus e, I'm going to do it like that, x to the power minus, and then multiple regression, right? Your intercept b plus m1 x1 plus m2 x2 plus dot 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 mk xk, right? Like this. This is one way. This is kind of a usual, normal way to record that, right? Alternatively, here is how you can write it differently. You can write it as natural log of odds that the response is equal to 1 is your linear expression. b plus m1 x1 plus m2 x2 plus mk xk, right? xk. Alright. These are completely equivalent ways to record the equation, right? You can do it like this as the expression for the probability, or you can do it like that as the expression that involves odds. And odds, reminder, odds for the event is the probability of that event divided by 1 minus p, right? Probability that the event will happen, that would be p, divided by the probability that the event will not happen. That's what's called odds. Okay? So I'm going to use this specific form. I'm going to use this specific form in order to write down my expression, okay, my equation. All right. So model equation: natural log ln of odds of 1, odds that the customer will agree to a loan, right? So income, intercept, first thing, right? Let me keep like 2 decimals, okay? I don't want to record everything down to the last decimal. So minus 12.71. That's my, and that also is common, right? Natural log. All right. That's my intercept plus 0.06 times income, right? Income is numerical predictor, correct? Yeah, it's a number, thousands of dollars number, okay? Family size plus 0.06, no, 0.6, right? 0.6 times family size plus 0.14 times the credit card average AVG balance, right? Okay. Now I'm going to skip Well, there's nothing else to skip, right? Everything else basically is categorical, right? So I'm done with my numerical portion, right? Now let's go on to categorical. I'm going to skip actually doctorate and MS. We're going to come back to that, okay? But a little bit later. Well, let's start with securities, right? So I'm going to start a new line. Plus, now securities account, it says security. My original variable is called securities account, right? But here I'm seeing something else. I'm seeing securities account yes. Why is it yes? Good. Because it's categorical and the responses in the file were yes and no. Remember we discussed that, right? If one of your predictors is categorical, R or any other tool, right, creates dummy variables, right, to represent the categorical variable. How many categories does it create? K minus 1. So in this case, CD account had two values, right? Two possible responses. Yes or no. You either have it or you don't, right? And which one is used as a base? Whichever one comes first, either numerically or alphabetically. So between answers yes, no, which one comes first alphabetically? No. So therefore it creates a dummy variable which corresponds to the second one, which is yes. Okay? That's why we have security count yes. And possible values for this one are 0 or 1, right? So, and I'm going to just keep writing that as if it was my numerical predictor, even though it's not, right? So I'm going to say securities account minus, right? It's actually minus 0.81 apparently, 0.8121 multiplied by securities underscore account yes, right? And therefore what will happen is, if they don't have a securities account, what's the value for this variable, securities account yes? It's going to be 0, right? No contribution, right? This term doesn't exist. But if they do have the account, then securities account yes equals 1, and we have minus 0.8121, right? Make sense? So I'm writing that as if they're just regular numerical predictors, nothing else, right? But I keep in mind that actually their values cannot be just anything, they're zeros and ones, okay? So I'm done with that one, all right? What's my next one? CD account, do they have it or not, right? So, and that's plus, right? Plus 3.98 times CD account yes. Same idea, right? Responses were yes, no. No comes first, alphabetically. So the dummy variable that was created is CD count yes, and it has value 0, 1, right? 0 if you don't have CD count, 1 if you do have CD count, right? Online banking, same deal, right? But it's minus, so therefore here I have minus 0.76, right? 76, I'm kind of rounding, times online underscore banking. Yes. Alright, let me jump to the next line. And the last line, credit card. And it's also minus, right? Minus 0.94 times credit card, yes. And that variable corresponds to if they do have a credit card with that bank or if they don't, right? Okay, so we dealt with simple categorical variables which are only yes, no. They're also called flag variables for obvious reason, right? To kind of tell you, is that a yay or is it a nay? Flag variable, okay? And the last one is going to be, the one that's complicated, education, right? How many levels education has? 3, right? We have BS, bachelor's, MS, master's, and docs for doctorate, okay? Which one comes first? Alphabetically. BS, right? Starts with B. Next one is D, and after that we have an M, right? And that's why, ladies and gents, we don't have the variable that's called education BS, no pun intended. Okay, that's going to be our base category, right? And everything else has a variable. Okay, education, we have MS, and education masters, right? So, and that's what I'm going to keep acting as if, like, you know, I'm just writing out things as they are spelled out in the output. So let's do the doctorate first, right? Education doctorate plus 3.82 apparently, right? Plus 3.82 times education doctorate, and also plus the last one is MS 3.8233. Well, here probably I'm going to need to give it a little bit more accuracy. For doctorate, I'm going to put 8183. Okay, and for the masters, I'm going to put 3.8233. Okay, times education doctorate. Okay, so that's my complete expression. Any questions, ladies and gents? Are we all okay? Yes, yes, sir. There is no bachelor, right? Because bachelor represents the base case, right? So in this case, my education really is encoded by using two variables, right? Education doctorate, and, oh, that's what you mean. Got it. Thank you. Yep. So this one is masters, right? Yeah, you're right. MS. This one is MS. That's what you were telling, right? Yeah. Good catch. Yeah. Thank you. I just basically recorded the same thing twice, right? Okay, so now I'm encoding the slope for the doctorate 8182. Yeah, you're right. 8183, right? 8183, right here. Is that right one? Okay, good. Yeah. So, if I want to include, for example, let's say a person has a bachelor degree. What's going to be the value of education doctorate? 0, right? And education MS, also 0. So there will be no contribution, right? What if they have doctorate? Then doctorate, education doctorate is 1. Therefore, we're going to have plus this to the equation, right? And education masters is 0. So that part is not there. What if they have MS? And this one is 1, right? Education MS is 1. Therefore, that gets added to the equation. But education doctorate is 0. And therefore, that is going to be the only contribution, right? That's essentially how it works, okay? Any questions, ladies and gents? Yes? No, it does actually. It does contribute to the equation. So, yeah, what Colleen is saying is, if there is no bachelor, that means that they have no effect, right? It was already accounted for over here in the intercept for the equation. Okay. So the fact that bachelors they do have some bearing, right? I mean, if somebody with bachelor comes in, at the end of the day, I want to calculate this probability of 1 for them, right? That's basically, and to see if that's above 1, or 0.5, or below 0.5. So therefore, I should be able to calculate that. And the base level, which is BS, right, bachelor's, is already included and accounted for in this one, in the intercept for the entire equation. Yeah. So everything else is kind of relative to the bachelor. Are they odds getting higher, or are they odds getting lower? Okay, that's basically the idea. Make sense? All right. Now, ladies and gentlemen, do you remember the rule that we discussed? What happens if the slope is positive for the variable? What does that mean? The odds of being a 1, response yes, are they getting higher or lower? Higher, right? And the reason basically is this, right? If you look at this equation, here's what happens, right? Let's income, for example. Okay, good example, the first one, income. if my income is getting higher, right, according to this equation, let's say, for example, income goes to income plus 1. And all incomes are in thousands of dollars, so plus 1 means what? Yeah, I'm getting an extra 1,000, right? I just got a raise at work, okay? Everything else stays the same, right? Family size, education level, online banking, yes or no, all of that stays the same. But I just got a raise, 1,000 extra dollars. So my income becomes income plus 1, right? That means that the right-hand side of this equation is getting higher, right? Natural log on the left-hand side, therefore, is also getting higher, right? Therefore, the odds of me becoming a 1, agreeing to a loan, are getting higher. And that drives up also the probability, right? Simple relationship, we discussed it, right? If the slope is positive, that increases the odds of 1, right? If the slope is negative, that decreases the odds of 1. So, therefore, what can we say? Income, increase in income results in what? In increase of the likelihood of getting a loan, right? What about the family size? Same thing, right? Does it make sense, first of all? Let's discuss this. Does it make sense? If you have one more family member, you're more likely to take a loan. Does it? Yeah, right? Because it's a burden, financially speaking, right? I don't know about all these, great things. Oh, children, they're so great. I don't know about that. But financially speaking, it's basically, you're worse off, right? No matter how you spin it, you're worse off financially, right? So therefore, you're going to get a loan more likely, okay, out of the bank. Okay, credit card balance. If you get a higher credit card balance, is that driving the odds up or down? Driving it up, right? Does that make sense? Yeah, I spend more on my credit card, right? Exactly. So that means that I need money, right? Simple as that, okay? So that probably increases the likelihood of me getting a loan from the bank. That makes sense, okay? Securities account. If I have the account, will that play in favor of me getting a loan or against? Against, right? Does that make sense? What's the securities account? Well, securities is more like probably online trading, that kind of stuff, right? So if you do the online trading, right? So if I do online trading, I'm less likely to get a loan from the bank. That's what it says, right? Does that make sense? Probably, right? Because people typically, when they do the online trading, they don't do it with their last money, right? It's the money that they can risk, given that the market is up and down, right? And if I'm not in a huge need of money, then why should I get a loan, right? So that may make sense, okay? That might be an explanation. Okay, then CD account. Presence of the CD account, apparently it raises the likelihood of me getting a loan. That one I can't explain, quite honestly. I don't know. CD account is like long-term account. Well, that might be it, right? CD account is a long-term saving, right? You can't touch it, right? So if you're committed to not touching the money, and all of a sudden you need money, what do? Well, get a loan, right? That might be it. Online banking. If you do online banking, does that play in favor of loan or against? Against. Does that make sense? Yes. How? You what? Yeah. Here's my explanation, okay? Like I do online banking, okay? If my bank offers me a loan, is that necessarily the best loan conditions, percentage and everything? No. Where do I find loans on the internet? You tell me, finance majors. If I want to get a loan from the bank, right, and I want like lowest interest rate, where do I go? Big banks. Well, I typically use bankrate.com. Okay, not that I'm getting loans, every day, but bankrate.com is one of the websites, right? Why should I just jump on this opportunity? Maybe there are lower interest rates out there, okay? my bank, with all likelihood, is not offering me the great. Yeah, exactly. So, therefore, people doing online banking, they're, well, let's call it internet friendly. So, therefore, they're probably more likely to find better terms and conditions somewhere else. Therefore, they're less likely to get a loan just because it's offered, right? Okay. Credit card, well, same thing, right? If I have credit card from the bank, then I'm less likely to get the loan from the bank, right? Because I kind of already got the loan from them in the form of a credit card, maybe this one, right? All right, this one, education doctorate, and that is relative to the baseline, right? So what do we say here? Doctorate, well, if I line, let me put it this way, okay? If I have 3 people, completely identical to each other, okay, in all respects, balances, family size, income, age, what have you, everything is the same, okay, except one is bachelor, another is master's, and third is PhD. Which one is the most likely to get a loan from the bank according to this? Master's, right? Why? Because it's the highest slope, right? The highest right side corresponds to the highest odds, right? And therefore highest probability. Make sense? Yeah, well, bachelors are already here, right? Bachelors are factored in here. That one is doctorate. If you're a doctorate, then this is the number which is relative to the bachelor, right? So bachelor is the baseline, and everything else is an adjustment, up or down, right? Depending on the exact thing, right? Yeah. So therefore, I know that if you're a bachelor, then the contribution is how much? 0, right? It's already included in the slope, right? In the intercept, okay? So the lowest between them, lowest contribution belongs to the bachelors, right? So therefore, they're the least likely to get a loan. The next one is MS, right? Because it's the highest contribution to the right side. And masters, or doctorates, right, is pretty close to masters, but slightly less, right? So doctorates are slightly less likely than the masters to get a loan out of the bank, right? So I can kind of arrange them in the order of highest likelihood versus lowest likelihood, okay? Make sense? All right. Yeah. I did put what? Oh yeah, well that's because it is. But because it's a dummy variable, right? And the levels are yes or no. The base level is the first that comes alphabetically, right? That would be n versus y, right? N comes first, so that's base. So therefore the variable really corresponds to another one, right? And that would be yes, okay? So here, for example, I have online banking yes, all right? If I don't do the online banking, that means yes equals 0, right? This variable equals 0. No contribution, right? But if I do online banking, then my online banking yes equals to 1, and therefore the right side is minus 0.76, okay? The reason why it's yes is because simply it's the second category alphabetically. No is the base and yes is the next one, hence we have a yes variable, okay? That's the only reason. Because, you know, imagine yourself being R. Stupid, I know it sounds stupid, right? Like, does it make a difference to you which category is first? Master's, bachelor's, doctorate? No, right? So you have to pick one as the base. Which one is that? Well, let's pick the one that's first alphabetical. Simple as that. Okay? And that's basically how the analysis is done. Right? How are we doing? Yay? All right. Let's quickly, in the remaining 3 or so minutes, do a very important thing. Okay? All right. Here is the question. Okay? Income. Let's take a look at income. All right? So here's what I'm going to do. I'm going to write down my equation in a very schematic way. Okay? Odds, natural log, right? Natural log of odds being equal to 1 okay, no, odd of 1, right, is my equation. So what's my intercept? Come on. Minus 12.71. Minus 12.71. Minus, right? Is it minus the next one? Plus 0.0597. Maybe exact. Okay, plus 0.597 times income plus the rest of them. Okay. So this is odds at some income level. Okay, at some income level. Now we discussed that income has positive slope. That means if I'm getting more income by $1,000, my odds are going up, right? I'm more likely to take out a loan. Let me go ahead and calculate the odds, the new odds, okay? So, natural log of odds of 1 at level income plus 1. So in other words, I'm getting a raise, right? I'm getting $1,000 raise. Great. And everything else is the same, right? Nothing changed. So I have still minus 12.71 plus, and now I have 0.0597 times, this time around it's income plus 1, right? Plus dot, everything else is the same, right? Make sense? So here's what I'm going to do. This thing keeps popping up. I'm going to take the expression 1 and subtract from that expression 2. Okay? So, on the right side, on the left side, come on, man. On the left side, I'm going to have natural log of odds at new income plus 1, right? This one right here, minus this one, natural log of odds at old income equals. Well, first of all, if I subtract the sides of the equation, this one and this one cancel out, right? It's the same thing, right? Do you agree that all this dot and dot also cancel out? Because it's everything else which doesn't change, right? So really what I have is an income times the slope minus income times the slope also cancel out, right? So all I have really a slope, 0.0597. And that one is slope of the equation, right? Does not depend on income, right? If I go from income to income plus 1, I always have this, okay? And by the way, also, what if you have natural, let's see how much you remember. Natural log of A minus natural log of B is equal to what? Exactly right, ln A divided by B, right? And that's exactly what I have over here, right? So, let's write it down. ln of odds at income plus 1, right? Income plus 1,000 divided by odds at old level before I got the raise is simply 0.0597. How do I get rid of ln? How do you reverse the ln function? E to the power this should be equal to e to the power that, right? So finally, here's what I have. Odds of me being a 1 at income plus 1 divided by the odds at the old level income is simply e to the power slope, okay, for income, or e to the power plus 0.0597. Okay, we ran out of time, I'm pretty sure, right? Okay, so next class, which is what, Wednesday, right? We're going to kind of unwind this expression and figure out something nice out of that, okay? And also we're going to discuss the accuracy, because so far we didn't even touch this, right? Okay, so